We'll be looking at the right triangle trigonometries, the sine, cosine, tangent, and the reciprocal functions in terms of the sides of a triangle. So SOHCAHTOA is an acronym to help you remember which sides ratios will give you sine, cosine, or tangent. So sine of theta is equal to the O stands for opposite side over the hypotenuse. Cosine of theta, A stands for the adjacent side over the hypotenuse. And then tangent of theta is equal to the opposite side. So we're going to just say opposite over adjacent. So I can mark these if I'm just have one triangle per problem. We can mark the opposite, the adjacent, and the hypotenuse. So given a right triangle, ABC with right angle C, find all 6 trigonometric functions of angle A. So let's draw a picture first. We should always draw a picture. Okay, so side A is opposite angle A, so this is 3. Side B is square root of 7. We are missing the hypotenuse. So we're going to use the Pythagorean theorem. A squared plus B squared equals C squared. So you have 3 squared plus the square root of 7 squared equals C squared. So 9 plus 7 is C squared. 16 equals C squared. You're going to square root both sides. You have one answer, it's positive because distance is positive. So 4 equals C. Now, we would like to mark a few things. So I'm going to put C as 4. If you look at your angle A here, the opposite side is 3, so I'm going to put OPP, or we could just put the letter O. The adjacent side is 7 because it's part of the angle of the two sides that form angle A. And then the hypotenuse is C. It's always across from the right angle. So knowing this, sine of theta is opposite over adjacent. So I'm going to opposite over hypotenuse. Opposite over adjacent is tangent. So sine of theta is SOH, opposite over hypotenuse. So 3/4. Okay, let me write that a little bit lower so we can see the reciprocal functions here. Okay, so sine of theta is equal to opposite over hypotenuse, 3/4. Cosine of theta is A over H, adjacent, square root of 7 over the hypotenuse. And tangent of theta is equal to opposite over adjacent, 3 over root 7. Now remember your reciprocal identities, we can just flip our fractions. So the reciprocal of 3/4 is 4/3. That's cosecant of theta. Secant of theta is equal to 4 over root 7. And cotan theta is equal to root 7 divided by 3. Let's look at another example. Given right triangle ABC with right angle C, find all 6 trigonometric functions of angle B if side A is 3 and the hypotenuse is 5. Okay, so let's put angle B as the highest angle. And we're going to look at what we have. Angle A is 3 and the hypotenuse is 5. That means we don't know side B. Now, if you've memorized your Pythagorean identities, it's a 3, 4, 5 angle. Triangle, not angle. Your side lengths are in the ratio of 3, 4, 5, so we expect B to be 4. But let's go ahead and work that out. So we know that A squared plus B squared is equal to C squared. So 3 squared plus B squared is equal to 5 squared. Nine plus B squared is equal to 25. B squared is equal to 16. B is equal to 4. Just as we thought. If you have not memorized your Pythagorean identities, that's okay. We can solve using the Pythagorean theorem. So that's a 3, 4, 5 triangle. So secant, let's start with sine. So sine of theta. Okay, so let's write our acronym down there first. So I know it's SOHCAHTOA. So using my acronym, sine of theta, in this case, theta is B. So let's say sine of B is equal to the opposite. Now let me show you what happens. On B, the 4 becomes opposite, and the 3 becomes the adjacent. And this is the hypotenuse. Okay, so opposite or across from the B is 4, so we have 4/5. Cosine of B is equal to the adjacent, which is 3/5, 3/5. And the tangent of B is equal to opposite over adjacent. Notice tangent of B does not involve the hypotenuse at all. So opposite of B is 4/3. Again, your reciprocal functions, cosecant of B is 5/4, secant of B 5/3, and cotangent of B is 3/4. Okay, so let's simplify the expressions. Let's go ahead and draw our 30, 60, 90 triangles and give them ratios. Okay. Now, in general, it's x root 3, and 2. But we can go to the most basic, which would be 1 root 3, 2 for a 30, 60, 90. 45, 45 is going to be 1, 1 square root of 2. These angles here are 45 degrees. Okay. So sine is opposite over hypotenuse. So if you look at your 30, 1 is across, so the sine of 30 is 1/2, 1/2. 4 times 1/2 is 2. All right, now this is a Pythagorean identity. Sine squared plus cosine squared. My answer is 1. Let me go ahead and show you using the numbers, plugging in. So sine of 45 is 1 over square root of 2, opposite over hypotenuse. Cosine of 45 is adjacent, which is also 1 over square root of 2. So if we do the math, that's 1/2 plus 1/2. 1/2 plus 1/2 is 1, which we knew was the answer. So if you recognize an identity, you can just go ahead and write down what the answer is. All right, we have a cofunction theorem. So a trigonometric function of an angle is always equal to the cofunction of the complement of the angle. So the two angles have to add up to 90. And the complement is 90 minus the angle. So for example, cosine and sine are cofunctions. And then tangent and cotangent are cofunctions. Secant and cosecant are cofunctions. So cosine of 40, so the sine is, this is equal to sine of 90 minus 40. 90 minus 40 is 50 degrees. So the cosine of 40 is equal to the sine of 50. Sine of y is equal to cosine of 90 minus y. Because sine and cosine are cofunctions. Okay, cotangent and tangent are cofunctions. So cotangent of 12 is tangent of 90 minus 12, which is tangent of 78 degrees. Now, let's just draw a picture. Let's look at this. Okay, let's do 40 and 50. Let's just do A, B, C. So off of the picture, what we've been practicing, cosine of 40 is adjacent, which is A, over hypotenuse, C. Sine of 50 is opposite, which again is A over C. So you can see if we look at a triangle and use the definitions we were using, we will get the same ratio. Okay, cosecant of 30. So again, I like to draw a picture. For your 30, 60, 90, and your 45, 45. Okay, and I'm not going to put the degree sign in there, just as a little bit too much there. All right, so cosecant of 30, so that's equal to 1 over the sine of 30. So if I can find the sine of 30, I could flip it. So sine of 30 is 1/2. Therefore, cosecant of 30 is 2. Okay, cotangent of 60. Well, cotangent of 60 is 1 over the tangent of 60. So same thing. If I can get tangent of 60, I could find the reciprocal, and that would be the cotangent. So tangent of 60, tangent is opposite over adjacent. So that's the square root of 3 over 1. Therefore, cotangent of 60 is equal to square root of 3. Okay, secant of 45. So secant of 45 is 1 over the cosine of 45. So cosine of 45 is equal to 1 over square root of 2. So therefore, secant of 45 is equal to root 2, or the square root of 2.